Hi, I'm Julia Watson, and I'm going to be talking about perspective taking and perspectival expressions. And I'm going to start by breaking down what each of these things are. So perspective taking has to do with the idea that people have different perspectives, and this affects what they say in conversation. To illustrate this, consider this cartoon image, which represents a speaker's perspective. And in this situation, the listener is on the opposite side of the array, and they can't see the object with the darker background since this slot is closed on their side. And from the speaker's perspective, the best descriptor for the highlighted object would be the medium glass. But if they say this, that would confuse the listener since the listener only sees two glasses. So in deciding what to say, there's this tension between the speaker's perspective and the listener's perspective, and this consideration of both perspectives in conversation has been demonstrated in several tasks related to reference. Work in this area thinks of perspective as inherent and as a general process that takes place in all conversation. Others use the term perspective differently to refer to a relatively limited set of expressions where perspective is required for interpretation. And one such example is the deictic motion verb come, which we focus on here. Come is most acceptable when a relevant perspective taker is at the destination of motion. So, like in this example, the speaker is at the destination. And although there's a lot of work on the verb come, it hasn't been explored in the context of general mechanisms of perspective taking. And through our analysis of come here, we argue that general mechanisms of perspective taking can explain use of perspectival expressions. And we do this both by running a production experiment as well as through computational modeling. This contributes to the perspective taking literature because it explores how perspective taking plays out in a new domain. As I mentioned before, much work on perspective taking has focused on reference tasks. This also contributes to work on perspectival expressions since it examines how their use fits in with other linguistic phenomena related to perspective. And this relates to the first of the two hypotheses we explore in this work, which is that use of perspectival expressions can be subsumed under the general process of weighting multiple perspectives in conversation. The second issue we explore in this work is the impact of uncertainty on perspective taking. And in particular, we're interested in how speakers behave when they have uncertainty about the listener's perspective. Continuing with our verb of interest, come, as I mentioned before, speakers are most comfortable using the verb come when a relevant perspective taker is at the destination of a motion event. This can be the speaker or it can be the listener, and speakers will rarely use the verb come when neither they nor their listener is at the destination. It's less obvious what speakers do when they're not exactly sure where the listener is. Previous work has looked at how uncertainty influences speaker behavior in a reference task, and here we look at the impact of uncertainty on a different kind of task. And this relates to our second hypothesis, which is that speakers will continue to weigh their perspective with their partners even when they have uncertainty about the listener. We test these hypotheses using an online production experiment. The first variable we manipulate is who is at the destination. This was inspired by an experiment from Anderson 2020, which also looked at the verb come. For this variable, we had 4 conditions named for who was at the destination of a motion event: both, speaker, listener, and none. So for example, in the both condition, both the speaker and the listener are at the destination of motion. The second variable we manipulate is whether or not the speaker can be certain of the listener's location. And this is an example of the both certainty condition, and the map unambiguously indicates the listener's location. To make this both certainty condition into a both uncertainty condition, we show a copy of the listener at another location, and the two listeners are shown in a lighter color and have a question mark above their head, and this is meant to indicate that the listener might be in either location, and participants were instructed on how to interpret this. And this shows examples of each of the 8 conditions with the listeners circled. The task was to communicate to their listener the destination of a third-party character named Rose. And we make predictions about these conditions corresponding to our two general hypotheses. For our first hypothesis, we make predictions about the certainty conditions. We predict that the rate of use of come will be highest in the condition where both the speaker and listener are at the destination, that it will be lower in the speaker and listener conditions, and lowest in the none condition. And this would provide evidence that the speaker is balancing their perspective with their partners. And it would show this because the only difference between the both condition and the speaker condition, and between the listener condition and the none condition, is whether the listener is at the destination. So if we find differences between these pairs of conditions, that shows that the speaker is taking the listener's perspective into account, in line with what has been found for other perspective-taking phenomena. Relating to the second hypothesis, we predict that in the uncertainty conditions, the speaker's use of the verb come will show that the speaker is not ignoring the listener, even though they're uncertain of the listener's perspective. And I expand on this more in the modeling section, where we use computational modeling to test different hypotheses about how the speaker takes the listener's perspective into account. So for the rest of the presentation, I'm first going to present the human experimental results, and then I'm going to present computational modeling. And these are the certainty results for come. And I focus on come here, but we show how other predicates are used across conditions in the paper. Remember that we predicted that come would be said most in both, less in speaker and listener, and least in none. And this is exactly what we find. This suggests that both the speaker and listener perspectives influence what the speaker says, in line with what has been found in other work on perspective taking, such as in reference tasks. And these are the uncertainty results for come. Remember that our second hypothesis was that the listener's perspective continues to influence what the speaker says, even in the uncertainty conditions. And looking at the results here, it may seem to contradict that hypothesis, since we don't see significant differences between both in speaker and listener in none, where the only difference is whether the listener is at the destination. So it may seem like the speaker is ignoring the uncertain information about the listener's location. However, as we'll show later, through modeling the data, we're able to better understand what might be underlying this pattern, and we make the case that perspective weighting is actually still occurring. From here, we move on to computational modeling. And I'm first going to talk about modeling the certainty conditions, and then I'm going to talk about modeling the uncertainty conditions. In predicting whether speakers use the verb come, the most relevant aspect of each perspective is where that perspective taker is relative to the motion event. So for example, in the listener certainty condition shown here, the speaker is not at the destination, but the listener is. And this is the information that we use as inputs for modeling. We model use of come using the multiple perspectives model, which has previously been used to model perspective taking in the case of reference. It formalizes the idea that the speaker weights the listener's perspective with their own in deciding what to say. The speaker's perspective is given a weight of omega, which is a value between 0 and 1. And when we increase this weight, the weight allotted to the listener's perspective decreases correspondingly. In modeling the data, we pick the value of omega that best fits the human data, and that can tell us about how much the speaker prefers their perspective relative to the listener's. One thing we haven't explained yet is that this model requires estimates of what would be preferred from each perspective. And we approximate this using data from conditions where the speaker and listener perspectives agree. So in the both condition, the speaker and listener have the same perspective on the motion event since they're both at the destination. And we use this to estimate the preferences of a participant who is at the destination. Similarly, in the none condition, the speaker and listener have the same perspective on the event since they're both not at the destination. And we use this to estimate the preferences of a participant who is not at the destination. We can plug these values back into the equation from before to make predictions for the conditions of interest. For example, in the listener certainty condition shown here, the speaker is not at the destination and the listener is, and we model use of come in this combination as a weighted combination of the rate of come in the none certainty condition and the both certainty condition. Going back to the key focus of this work, which is to examine the relationship between perspectival expressions and perspective taking, what do we gain by using this model? The multiple perspectives model has previously been used to model how speakers weight perspectives in perspective taking more generally, and if we find that it can also capture how people use perspectival words like come, this suggests that use of perspectival language can be subsumed under the general process of weighting multiple perspectives in conversation, which supports our first hypothesis. Now that we've discussed our modeling approach, we can assess how well the model predictions fit the human experimental results. And here we aim to predict the rates of come for the speaker and listener conditions based on the both and none conditions, which is why the speaker and listener bars are shown in a different color. And we find that the multiple perspectives model achieves a near identical fit to the data, and this strong fit suggests that perspectival language use can be subsumed under the general process of weighting multiple perspectives in conversation, which supports our first hypothesis. So now I'm going to show how we extend our modeling from the certainty conditions to model the uncertainty conditions. Remember that this is how we predicted the rate of come for listener certainty. I'm going to compare the listener certainty and listener uncertainty conditions to illustrate how we model the uncertainty conditions in general. So in comparing these two conditions, the speaker's perspective stays the same, since the speaker's location hasn't changed. In contrast, we now have two possible locations for the listener. They might be at the destination, or they might not. And to model this, we look at different ways of combining what's preferred from each of the two listener locations, and we use the same base conditions as in the certainty modeling. And here I broke down how we model the listener uncertainty condition, but we use analogous approaches for modeling the other uncertainty conditions. So looking again at the human experimental results for the uncertainty conditions, I mentioned before that it may initially seem like speakers are dealing with uncertainty by ignoring the perspective of the listener entirely. And this motivates testing the null hypothesis that the speaker simply ignores the uncertain information about the listener's perspective. Computationally, this means we fix omega to be 1, which assigns a weight of 1 to the speaker and 0 to the listener's perspective. This model's predictions are not a good fit for the data, since it predicts higher rates of come in the both and speaker conditions than we found experimentally. Connecting back to our hypothesis, the poor fit of this model to the data suggests that the listener's perspective affects what the speaker says in the uncertainty conditions. With this in mind, we modeled two possible ways the speaker may take the listener's perspective into account. First, we model a speaker that takes both possible listener locations into account and assigns them equal weight. Although this seems to fit the data better than the null hypothesis model, it predicts differences between the both and speaker conditions and the listener and none conditions, which isn't consistent with the significance testing results. The last model we consider is one where the speaker ignores the possibility that the listener might be at the destination, and instead focuses on the possible listener that is not at the destination. This would explain why we don't find differences between both and speaker and listener and none. And with this model, we find an extremely strong fit to the data. One explanation for why speakers would behave this way is that they are cautious about using the verb come when they aren't completely certain that someone is at the destination, so they conservatively behave as though the listener is not at the destination. Connecting back to how speakers integrate uncertain information about the listener, we find the best fit to the data when we use a model that considers the listener's perspective. This supports our second hypothesis that speakers continue to take the listener's perspective into account even when they are uncertain about the listener's location. And we were only able to show this by looking at the data through the lens of computational modeling. To sum up, we ran a production experiment and performed computational modeling to test two hypotheses, and we found support for both of our hypotheses. First, we found that use of perspectival expressions can be subsumed under the general process of weighing multiple perspectives in conversation. And second, we found that speakers continue to weigh their perspective with their partners even when they have uncertainty about the listener. Thank you.